Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers. Here is another video on calculus, especially in functions, sketching graphs, and functions, formulating equations. So a man drives from Davao City to Cagayan de Oro City, say 300 kilometers at an average speed of 60 kilometers per hour, stops 1 hour in Cagayan, and returns at a speed of 50 kilometers per hour. Neglecting variations of speed in the route, graph the speed v as a function of time. So here is it. Here it is. The speed of the car is 60 kilometers per hour for from 0 to 5, and it should be graph as shown. So 60 kilometers per hour, we have the speed here in the speed in kilometers per hour, then time in seconds. So 60 kilometers per hour from 0 to 5. Then from 5 to 6, 0 to 5 hours, because 300 kilometers divided by 60 is 5 hours, so the time should be 5 hours. You have to consult the preceding video because this problem was also presented in the preceding video. So that's why it will take 5 hours for that car to reach Cagayan de Oro City. Then between 5 and 6, the speed is 0 because the car stops in Cagayan for 1 hour. So it should be sketched as shown. We have an open dot for 5 and 6, then close again 6 to 12 hours because in going back 300 kilometers divided by 50 kilometers per hour, that will take 6 hours to go back to Davao City. So the graph would be 50 kilometers per hour speed, that speed up to 12 seconds here as shown in the figure. So that's it. That's the graph of speed as a function of time. Then for the next problem, an open top box is made of cutting equal squares of side x out of the corners of a piece of cardboard 8 inches square and turning up the sides. So let's have the figure as our guide. Then in the problems later in calculus, this should not be given anymore. It's part of the viewers and readers to analyze the situation, formulating expression for volume of the box. So plot the volume V as a function of x when B. Find x if volume is 37.5 cubic inches. Then find x that maximizes the volume. So the method to be presented here in finding x is method that is based on the graph and by common sense also. Later on, this x here is to be determined officially by maxima minima technique or approach. So this is the given figure. This is the square uh, sheet, 8 inches by 8 inches. Then we have to cut equal squares, these blue squares here of dimension x by x, so that the remaining dimension for the base of the box would be 8 minus 2x, and the height of the box would be x after we bend this part here and turning up the sides. So the box will look like this. So the base is square with dimensions 8 minus 2x by 8 minus 2x, and the height of the box would be, after we fold this, along this and along this edge or along this line would be x. So that the volume is length times width times height, or area of the base times height. So 8 minus 2x quantity squared times x. So volume equals quantity 8 minus 2x squared times x. We factor out 2 in this parenthesis here. So volume equals 2 times quantity 4 minus x squared times x. Since 2 squared is 4, so volume is 4x times quantity 4 minus x squared. The domain of this function is 0 to 4. Because when x is 0, volume is 0, and when x is 4, volume is also 0. So that should be the domain of x, or the domain. Then from here, there is this dimension x such that the volume would be maximum. But before that, let's plot the volume as a function of x. So when x is 0, volume is 0 as shown. So it will begin with volume 0 here. Then x is 0, volume is 0. When x is 1, 4 minus 1 is 3. 3 square is 9. Then 4 times 9 is 36. So we have 1 comma 36 as shown. 1 inch, then 36 cubic inches volume. When x is 2, this is 4 minus 2. So 2 square 4. 4 times 2, 8. 4 times 8, 32. So we have also, when x is 2, volume is 32 cubic inches. Then when x is 3, 4 minus 3 is 1. 1 square is still 1. 4 times 3 is 12. So we have 3 comma 12. And lastly, when x is 4, volume is 0. So the graph will look like as shown. So therefore, the maximum volume occurs somewhere here between 1 and 2. But we will estimate it further by answering the second part. If the volume is 37.5 cubic inches, because it is greater than 36, so far it's 36 here, but there is a peak point here, and it is greater than 36, that's why the volume is 37.5. So equate volume 37.5 equals 4x times 16 minus 8x plus x squared. After we expand this part, then 37.5 equals 64x minus 32x squared plus 4x cubed. So rearranging, 4x cubed minus 32x squared plus 64x minus 37.5 equals 0. Then using your calculator, which is also capable of finding roots even if it is a quartic equation, then we have the following three roots. One is x sub 1 is 5.327 inches, and it is an absurd value because the domain is 0 to 4. So that means this is outside the domain and it cannot be. Then the next root is x sub 2, which is 1.5 inches, and that is an okay because it is within the domain. Then finally, x3 is equal to 1.173 inches, and that is okay also because it is between, or it is inside the domain. So therefore, the answers would be, when the volume is 37.5 cubic inches, then the value of x would be 1.5 inches and 1.173 inches. So that leads us to the conclusion that the maximum volume occurs between these two values here, because 37.5 is not yet the maximum volume. So we have an idea that the dimension x that will make the volume maximum is between here. So let us evaluate volume from this formula here. When x is 1.3, because 1.3 is somewhere between 1.173 and 1.5, and the volume is equal to 37.908, which is greater than 37.5. Then let's try 1.33. 4 times 1.33 times 4 minus 1.33 quantity squared. The volume is greater than 1.3, so that means it increases. Then volume when the dimension x is 1.34 is 4 minus 1.34 square. So volume is equal to 37.9252, so it decreases. So therefore, the dimension x corresponding to maximum volume would be between 1.33 and 1.34. And that value is, of course, if you say 1.335, but we jump to the conclusion that it is 4 thirds, because 4 thirds is 1.33333, and that is between this value. So when the dimension is 4 thirds, and it should be greater than these two values here. So in decimal, the volume is 37.9259, and in fact, it is greater than these two values here. Therefore, we conclude that the dimension x corresponding to maximum volume is 4 thirds inches. So that's it for this video. I hope that you enjoyed watching and you learned something in from this video.